Welcome back to the deep dive. If you're looking for that shortcut to really mastering complex aircraft systems without, drowning in technical manuals, then you are definitely in the right place. Today, we're diving deep into, the digital backbone of the modern cockpit, electronic flight information systems, EFIS. And this whole analysis, it's really custom built for you, the ATPL student. We want to help you translate those dense operational principles into clear, testable facts you can recall instantly, helping you nail those theory exams.
That's exactly right. Our mission today isn't just about definitions. We're zeroing in on the specifics, the real nuances, things like the color codes, the exact display procedures for decision height, the limitations, between different nav modes, and those critical redundancy features. We're basically unpacking the core components, the displays, the modes of EFIS to make sure you've got rapid, accurate recall, and importantly, you can differentiate between terms and concepts that sound similar. Success here often boils down to mastering those specific differences.
Yeah, get those details right. Our source material comes from detailed operational excerpts, design documents, basically covering everything from the guts of the symbol generator to the subtle differences between MAP and plan modes. Keep these points locked in, and you should be well prepared for what the examiners might ask. Okay, let's unpack this then. We should probably start right at the foundation, the architecture of EFIS itself. What exactly is this system, and why was it such a massive leap from the old steam gauges?
Fundamentally, EFIS is the electronic replacement for those older mechanical instruments. Its main job is to integrate and display all the attitude, heading, and navigation info onto two main electronic screens. You've got one screen focused vertically, that's attitude, and one focused horizontally for navigation. These displays, they can be the older cathode ray tubes, CRTs, or the modern liquid crystal displays, LCDs. And the key benefit, which sounds simple but is huge, is that the standardized graphical format is just vastly easier to read. It takes less scanning effort from the pilot, and honestly, it's far less likely to be misinterpreted compared to, a dozen mechanical dials scattered across the panel. And crucially, EFIS is totally integrated with the aircraft's digital brain, the computer-based navigation and flight control systems.
Right, and we look at a modern flight deck. EFIS isn't just one single box, is it? It's more like a distributed system built with redundancy in mind, especially for the two-pilot crew.
Precisely. To really get it, you have to know the 5 essential units that make up each pilot system. So the captain's side and the first officer's side have their own set.
Okay, give us that list. What are the 5 key parts?
All right. First, the vertical display. The Electronic Attitude Director Indicator, or EADI. Nowadays, we mostly call it the Primary Flight Display, or PFD. Second, the horizontal one. The Electronic Horizontal Situation Indicator, EHSI, now generally known as the Navigation Display, or ND. Third, you've got the control panel. That's your main interface for modes, brightness, all that. Fourth, the symbol generator, the SG. Think of it as the dedicated processor for the visuals. And fifth, the remote light sensor unit, which handles the automatic brightness adjustment.
Okay, I want to pause on number 4 there, the symbol generator. In today's world with super fast processors everywhere, why does EFIS often still rely on this dedicated central SG? Why don't the displays just handle their own processing? What's its special job?
That's a really fundamental question, actually. It gets to the heart of aviation system design philosophy, The SG isn't just a simple computer. It's the critical hub for processing and, importantly, translation. Think of it like this. The aircraft systems generate signals in all sorts of formats. You've got analog from older sensors, discrete on-off signals, and modern digital data streams from FMCs, IRSs. The SG's main role is providing that crucial signal interface. It handles the analog, discrete, and digital conversions needed between all those different systems, the display units themselves, and the control panel inputs. Without the SG, the PFD or ND would just get a jumble of incompatible data.
So it's translating all that raw data into the symbols and colors we see, but you said it does more than just translation.
Oh, absolutely. Beyond just translating, the SG is responsible for symbol generation monitoring. It's constantly checking the quality.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best